We're good to go, right? Howdy, y'all. Welcome to Build. Who's excited to be here? This is the first day of one of the biggest developer conferences in the world, right? Aren't we all pumped? Right? All right. And secondly, I'm super happy that so many people in the audience share my opinion about this session being the most valuable and the most awesome in this time slot. So, welcome. Thirdly, I'm going to promise you this is going to be the session that's going to get you to code fastest. So if you're here to see app code, people slinging stuff, breaking stuff, all of that is going to be right here. So let's get started. You're going to need to help me to get there quickly. So I have a question to get started. Who in this room, until they read this agenda or this abstract, has never heard of ACA before? Azure Container Apps. All right, one person, we're doing good. Who has used ACA but isn't running anything in prod? All right, so we got, you're particularly welcome. Hint, hint. And then who in here is running stuff in production on Azure Container Apps? All right, good, thank you. All right, so let's go over the agenda. Where's my clicker? Sorry, see, screw-ups already happening. Let's go over the agenda. We have a hell of an agenda. I would actually like to say that this is probably the most aggressive session at Build, because we're going to have 3 people up here. Every single person is going to do a demo. Every single demo is going to be live. And we are all going to have an awesome time, because there's going to be interactivity, and there's going to be NFL, and then there might actually be figurative as well as literal tears. So let's hold on. So all of this is being made possible by Azure Container Apps. And I just want to highlight, this is our show, because Azure Container Apps is a developer-first service. We don't, I have to say this quietly, this part, we don't care about IT. And IT does not like us, because we are here to empower and democratize access to what developers need to deliver fast. It doesn't matter if you need to go from 0 innovation or all the way up to hyperscale. ACA is for you. Best of all, and your DevOps team is going to love this, there are no chores. We take care of them for you. The Azure Container Apps team is the team that does all the nasty upgrades and the troubleshooting and all that stuff. You can just deploy and run your apps. And lastly, and most importantly, and this is what this session is about, it's speed. You'll see today that we have an app that is prototype. That's mine, because the only reason they have me up here is because I don't mind making an ass of myself. Secondly, we're going to see a day 2 app and all of the things that people struggle with apps. In day 2, the gnarly debugging and tracing and what the hell is happening. Sneha is going to do that. And then, to keep us honest, so we're not just selling you and lying to you up here, we're going to have a production customer up here talking to you about how they delivered something in 2 weeks into prod. All right, let's get this going. Sneha is up next. And this is always the best. She's a developer on the Azure Container Apps team, and she's going to walk us through how easy it is to get started with Azure Container Apps.
Hey everybody, it's really nice to see all of you here. I'm Sneha Parthasarathi. I'm an engineer on the Azure Container Apps team. Today we're going to deep dive into a lot of exciting scenarios on ACA. We're going to see getting started scenarios. We're going to see rule-based routing. We're going to see logging and telemetry using OTel and Aspire. So let's get started. Today we're going to see a cloud petting zoo demo app, which pretty much has 5 microservices, which represents 5 pets deployed as container apps in the Azure Container App environment. We have a front-end application, which is a React application that is talking to these services, also deployed as a container app in the same container app environment. The front-end application talks to these services using rule-based routing. Each of these services has the OTel SDK instrumented, so these export OTel metrics to the OTel collector inside of the ACA infrastructure. The Redis cache stores the mood of the pet. So by the way, the user interactions is going to influence the mood of these pets. Now that we have the architecture, let's get into the code a little bit. Like I was showing you earlier, these are my 5 services that represents 5 pets. And we have a front-end application, which is pretty much a standard React.js application. You may ask, how are all these wired together? The answer is rule-based routing. So let's look at this. Let's look at this .env file real quick. You can think of rule-based routing as a smart managed API gateway, which essentially lets you define rules for your incoming HTTP requests. It lets you rewrite paths and also lets you configure a destination. It could be a container app, a revision, or a label. As you can see here, when you set up a route on your environment, it's a single FQDN. So it's essentially a single entry point to talk to all of your microservices. This way, you're abstracting your backend services and your front end. So they don't need to know about each other, but yet it's still modular. OK, now that we have a good idea of what the services are, the front end, how they talk to each other, time to reveal the app. So that is your cloud petting zoo. So essentially, you would pick each of these pets, and you'd be able to interact with them. That would essentially influence their energy levels, happiness levels, and chaotic levels. Now we're going to see how to actually deploy one of these apps to Azure Container Apps. So I have this command up already. Essentially, all we need to do is we can use AZ-CLI and the AZ Container App create command to actually deploy an app to Azure Container Apps. Here, as you can see, we have a few arguments like the resource group, the environment. We're also enabling ingress. We're setting the target port. And we also have some scaling. We're setting min replicas, max replicas. So this just tells the container app to auto scale. And min replicas make sure that there's always 6 replicas to make sure that there's quick cold start times. And max replicas tells us that it would scale up to 60, depending on what the scale rules have said. OK, awesome. So let me go ahead and run the command. OK, great. So while that's running, I have an app that's already deployed. So it would kind of look like this. So when you deploy a container app, it would spin up a new revision. And you're also able to see your ingress and all other settings here. So here, you would essentially see your image. And you'd be able to see your scale and things like that in this scaling configuration. So here, as you can see, there are 6 min replicas that we set, and the max replica is 60. Let's go look at the health probes. So the health probes essentially help us monitor the health of the apps. There are 3 kinds of health probes: the startup probes, liveness probes, and readiness probes. So let's go and set each one of them. I have the endpoint set to health Z, so I'm going to set that. Awesome. So let's go and save that new revision. So what this would do is essentially create a new revision with those help probes. And those help probes are going to send metrics to our endpoints to make sure that we can monitor our apps appropriately. OK, great. So now I am going to reveal the app. Go ahead and scan this QR code so you can interact with the pets yourselves. With that, I would like to hand over to Easy to show us how easy and fast it was to deploy their container app in just 2 weeks to production.
Thank you, Sneha. Hello, hello. Thank you, Sneha. Hello, everyone. I'm Isi from Southworks, and today I'm going to show you how we build some AI capabilities on the NFL Combine app. And where is the clicker? Sorry. There we go. But, not working? One, sorry. There we go. Sorry. Before diving into the details, let me set the stage. The NFL Combine is an annual event where football college players showcase their skill to coaches and scouts. Coaches, during the event, access players' data and test results right on the field using their Surface laptop. This year, we enhanced the experience of the app with AI-driven insights, but as Simon was saying, we had really limited time to deliver this, so we wanted to focus on building the AI features. That's why we chose Azure Container Apps, because it provided us with a fully managed compute layers that allow us to scale on demand without handling all the traffic that happened during the event, without worry about managing the infrastructure. However, this NFL Combine app has been around for a while, right? So there was a lot of room to make improvements leveraging AI. For example, gaining insights during the event was really time consuming. You know, all the manual analysis, go through the result either of the player or the test could take hours or even days, right? Also doing comparison about the different players could be really error prone, and that could lead to inaccurate conclusions, right? So what we did was building a Copilot-like experience, leveraging Azure AI Foundry that allowed the coaches and scouts to ask questions right in the app using natural language and get insights really fast. Let me do a quick demo. And there we go. Yep, perfect. Let me open the NFL Combine app here and go to the chat experience, right? So imagine I'm there on the field, I'm a coach, and I want to know the wideouts players, right, over 6 feet, right? So I can type this, send a message to the chat, and in a couple of seconds, I will get the response. And here we are. We have 3 players that match this criteria, right? Now, I want to know a little bit more about these players. So, for example, how they did on the 40-dash times test. So compare the 40-dash times, right? And let's see, this should come back with the result of how these players did on this. And there we go, right? We see how they did it. They match the criteria of the height, and there we go. Now, another scenario that is really interesting that now they can now leverage is because they have historical data, they can go over and ask questions from the previous years. So I can ask, for example, fastest player in the last 5 combines. And this will go through, navigate through the different data that we have, and there we go. We have 3 results, and interesting enough, none of them are from this year. So what happened here? Let's deep dive and let's ask the chat to compare with the fastest on 2000 in this year, right? And we'll see. Hopefully this will come back with an answer and we'll see what happened, right? There we go. We are seeing this, and There we go. The fastest players in the NFL Combine was Xavier, that it has there we go. This is the fastest players that we have in 2025, and as you know, the dash time is like higher than the ones that we have on the previous years, right? So that's it from the demo. Let me go back to the presentation here. Number one. Okay, let me deep dive a little bit about the solution architecture. The chatbot experience from 10 that I just showed is a standard web app that was built in React.js and is embedded within the Combine app. The backend is an API-driven agent that is hosted in container apps, which of course provided us the high performance, security, and scalability required for the event. The API integrates with Azure AI Foundry, and more specifically, with Azure OpenAI models, right? The data, as you see in the diagram, is stored in Cosmos DB. We also use Azure Container Apps shops as a reliable backend to process the data ingestion that we are doing in the application. We are retrieving data from the National Football Scouting API and storing that on Cosmos for fast data access. So, the feedback after the event has been amazing. With all this AI enhancement, the experience for coaches and scouts has been transformed. They now get instant player insight. They can even compare players, as I did in the demo, really quick on the field, and now they can get the data they need when they actually need it, something that before was taking hours and now takes seconds. Thank you so much. If you want to deep dive a little bit more about this scenario and other sport use case, my colleagues at Southworks are presenting tomorrow and Wednesday, so we'd love to see you there. Thank you so much. Back to Microsoft.
Thank you, Easy. So we had a chance to run a load test on this app that I just showed you guys. Let's look at how the scales are doing. So we started out with 3 replicas, and it looks like it responded pretty well. There are like 6 replicas now. So it's scaled. So it's responded to our load test. Let's look at this app again. You see how there's an issue here. So this is not an actual failure. This has been simulated to actually debug a live site incident today. So now that we saw getting started scenarios, we learned about rule-based routing, we even listened to our customers, and we learned about how easy it was for them to deploy their app to production. So now let's look at telemetry using OTel and Aspire. As you can see in this diagram, essentially these apps that are deployed in the Azure Container Apps environment are instrumented with the OTel SDK to export OTel logs to the OTel collector in the ACA infrastructure. And these OTel logs are then exported to the Aspire dashboard OTel endpoint. Additionally, users can also configure their own exporters like Datadog and Relic. But if they were to do that, they'd still have to configure their own exporters by themselves. But if they were to use the Aspire dashboard, everything is pretty much managed for you. The Aspire dashboard component manages authentication. It manages configuration for OTel. It also injects some other environment variables that you would require. Awesome. Moving on, let's actually go look at the Aspire dashboard. I have it set up here on this environment, so let's open this up. So this dashboard is using the 9.2 versions, which has some other cool things. Like it shows the revision information. It has information about the image that's associated with your container. And if you look at the details here, you'd also be able to see some other information like the running status, the time it started, and you'd also be able to see the environment variables you set up and the child, which corresponds to the revision. OK, great. But we still need to debug that incident that we were seeing. So let's go look at the structured logs. Before we deep dive into this, I want to talk a little bit about OTel metrics and OTel data. OpenTelemetry or OTel is essentially a cloud-native project which is a standard way of collecting traces, metrics, and logs. Logs essentially tells us what the exception is, traces tells us where the exception occurred, and metrics pretty much tells us how many times. So it's very useful to debug distributed applications in a live site incidents of real time. So let's go take a look at one of these logs. So what does this tell us? This has a lot of information. It has information about what the exception is, what the stack trace is, the type of the exception. It also tells us the service name, the service namespace, all of that good stuff. Additionally, it also has a trace ID. And trace ID is super important while debugging live site incidents because they give us a context of the lifetime of the entire request. When a request flows through service A to service B, what traces does is it adds context to where it originated from and where it's flowing through. So let's go look at the traces. Okay, awesome. We're seeing 5 levels of traces here. So this essentially tells us where it originated from. So this tells us that there was first a post request made to this pet interact endpoint, and then it went to this octo interaction endpoint, then it tried to get state from Dapper, and then it reached this endpoint, poke octopus, and this tells us poke started, and now this says there was a throttling check. So let's go look at that. So each of these traces has a lot of information, again, with the throttling reason, why throttling was applied. It even has a value for the chaos. Remember how I told you if you poke the animal, the chaos level increases? So it seems like the load test increased this by a lot. So let's go look at the code and see where this exception occurred. But before we do that, it might be nice to see the metrics here. Going back to the trace, it's important to note this suffix because we would use that to see corresponding metrics as well. So let me go do that. So this tells us the errors, and this also tells us the reason for that error. So we already have great information about what the error is, where it occurred, how many errors, and things like that. So now let's go into the code and see where this actually occurred and how to fix it. Ah, there it is. So that's the error that we were seeing. And what does this tell us? This tells us that the chaos level actually exceeded the threshold. If you remember, we saw 1425 as the value there, but that's way above the threshold value. So let's go fix this. Let's go change this to 3000. I'm going to build this image now, and then going to do a redeployment. So what this would do is it would create a new revision with the new image that we just pushed out. And we'd be able to see the status of the revision and what that looks like. So here I used the AZACR build command, but you could also use Docker build to build the image and push the image itself. I like the AZACR build just because it builds your image and pushes it, so it's pretty convenient. Okay, that seems to be taking a little while. But let's just go and see what that would look like. So when a new revision pushes out, we would be able to see a new revision spinning up here. And we'd also be able to see the status of the revision. If we go into the revision details, we'd be able to see if it's active or if it's running. Additionally, ACA also provides a way to look at metrics or just logs if it's a failed revision. Let's go back and see if it's successful. OK, awesome. That was successful. Now that we have built the image, let's go actually change the image. So we can do that by going into the containers, and that was v2. So we can choose v2 here and save as a new revision. OK, great. So that created a new revision now. You see how it's activating? So while the new revision is activating, the old revision is still running to make sure there's no loss in traffic. But when it finishes activating, the new revision is going to be running, and the old one will start deprovisioning. It takes a few minutes. We can go look at our app and see if it's still in a good condition or if it's still failing now. You see how this, on the Aspire dashboard, we're seeing two revisions now. One is still activating and the other one is running. That would be the same as what we're seeing in the portal. So the status that we're seeing on the Aspire dashboard accurately reflects everything that's happening in the portal. So it's seamless. Let's look at the logs. OK, great. So it's successfully provisioned and it's running now. So now the traffic is going to be routed to this new revision because I've enabled the single revision mode. But you can also enable multi-revision mode and have your traffic split across multiple revisions. OK, awesome. So with that, we actually saw getting started scenarios. We learned about rule-based routing. We heard from our customers, and now we even debugged a live site incident. So over to Simon to end the session and show other cool stuff on ACA.
Thank you so much, Sneha. This was awesome. Where's my slide? Where's my slide? Where's my piece of paper? So you know that Sneha is a developer because she literally got a just-in-time escalation request while she was doing a demo. So let me, yes, back to the slides because it's the product manager, right? No, seriously now. We are going to go and look at this right here. So I am going to go and attempt to show this app. This is totally never tested. I just, before I came on stage earlier, I deployed the last version of the API and the front end that you see right there. I have no idea whether or not it will work or not. And then this uses distributed task scheduler, which is also being released into public preview. This is a pretty cool service. It basically allows you to orchestrate a variety of various endpoints and microservices to talk to each other in a reliable way. We're going to look at that. And then most importantly, as I think is the most awesome, we are going to use an image model in the model as a platform format. That means that we're not just using an API and someone else hosts it, but we're using the strength of ACA and the flexibility it offers to give you the best of both worlds, choosing the very model you want to run, as well as doing so on serverless GPU at very low cost. And then we have OpenAI GPT-4 to do some laboring here as well. So yeah, I call this the storyteller app. It kind of was supposed to be a companion app to Sneha. But as most things go, sometimes. So let me switch over to number, I apologize, 4. All right, so I'm going to walk you through this app. As you can see, this is currently deployed right here. We have all of the various applications deployed. They're all running in the same environment. And I'm going to just kind of show some bits and pieces here. So I think this is probably the most exciting pieces. So here, what you're seeing is the full flexibility of ACA. And earlier, I talked about how this is a very powerful platform. It allows you to scale from 0 to hyperscale. What you're seeing here is actually, and not just like on the same platform, but literally on the same environment, in the same environment. And so these workload profiles are a pivotal aspect of this kind of opportunity or this possibility of growing. We have a series of basically types of workload profiles. There are consumption-style workload profiles. These are pools of resources that the ACA team runs for you, and you can basically use them in a pay-as-you-go format. You only pay for them for as long as you're running on them, and then when the app doesn't run anymore, for example, it scales to 0, or you delete the app, or you stop the app, you automatically stop paying for it. And then what you're not seeing here are our dedicated workload profiles. So all you're seeing here, with the exception of, let's see, yeah, so all you're seeing here is consumption workload profiles, and then we have some dedicated workload profiles. All the compute form factors, all the GPUs are also available as dedicated workload profiles. So if you need maximum performance, if you need hyperscale performance, then you can seamlessly switch over to dedicated workload profiles and basically then pay in a very similar fashion. Again, we automatically manage your nodes for you. But yeah, so this is kind of how the app and how my environment is configured. Here are all the applications. I'm going to kind of just browse through them. So we have various GPU and big GPU. We have my story API, and we have my story worker right here. And so let's take a look at this application. I have this application deployed. This is my API. The API is being served by just a very basic kind of, either you get a story or you get images. The important part about this piece is this is not hooked up to a REST endpoint or somehow. So when I say images, it obviously goes to the GPU, and it then goes and accesses or tells the GPU to render the image and basically return this back to us. In this case, this goes to the distributed task queue, not directly to the API for the GPU model. And so the distributed task queue then dispatches the worker. The worker does the work and then comes back. The beauty about all of this is if there's failures, if there's repeats, or you need to get a look in what's actually happening, that's very easy to do. So let's do some of that. First, I'm going to just try to do a very basic story. And basically, I'm just going to go simple button here, execute this. This is all about our petting apps. So there's a base prompt already installed. It's going to say, hey, tell us about Emo Octo and Cloud Turtle. No, what? Yes. So the story is basically going to tell us all about this. And as you can see, we get the story back. Don't attempt to read. We get the story back, and we can basically go and do stuff with it, basically. Next, let's see us getting images for this. So what I'll do is, and don't worry, I have an API as well, for an app as well for this, but for this purpose, I'm going to just use this very primitive method of copy and pasting. One-handed on a touchpad, that's how you know I'm a pro. I'm going to fetch images and post this in here. And what's going to happen next is this is a separate orchestrator. So the first orchestrator was very easy. It was just basically, hey, get me a story. And then the worker got the dispatch, and then it basically went to OpenAI and got the bits and returned them back. This time around, we're going to do a slightly more complicated, we're going to use a chained dispatch and then a fan out with the queue as well. So same process. The API is going to go and access the distributed task queue, then going to go and say, hey, first I need this story to be broken up into a storyboard, right? Because you can't just generate images off a storyboard. And then we're going to go and take that storyboard, and we're going to go generate images for every single one of those storyboard pieces, OK? So let's see if that worked. Again, this piece I've tested before. This is the third time I'm running it. And you can see, look at that. I am the luckiest man alive today. It actually worked, and we are getting pieces back. So, all right. We're not going to look at this in many more details. So, and then this is the front end. So all I'm going to show you, we're not going to go look at this a whole lot, but this is our GPU API. Here, I'm going to just show you one thing. I'm going to show you that we have a model-ready endpoint. At the moment, I'm going to say it how it is. It is extremely painful, or some people may say it is a pain in the ass to currently package these models. We're working on improving this piece. In the future, this will be very easy to do. But for now, it's slightly a bit more complicated. But what we did was we basically took a model from Hugging Face. We packaged that model inside of a container image. Then we deployed it on serverless GPU. And this model is now running via an API endpoint for us to go and inference against. So let's see if this app that I deployed 3 minutes before walking into this room actually works. I even prepped a special prompt that I'm going to go and pull out now somewhere. Not here, though, but here somewhere. See, I pretend to be a developer. That's why I have all this stuff on the screen. Hold on. It's almost there, almost there, almost there. At this point, I could have just typed it out. Boom. This is very meta. So that's what happens. I'm really hoping for the best. Again, just to repeat, this front end runs on the same thing that we looked at earlier for images and story. It now goes out, it dispatches a request to the distributed task queue that was at the bottom. That's why I'm making this like left-right motion every time. And then this gets dispatched to the worker. The worker does the work of basically fetching the story from OpenAI and then returning that story. And boom. So I'm so happy about this. I got to share. This is O3 that just basically turned this from an ugly, unformatted string before I walked in and deployed this app into something that is now actually formatted properly. I am so excited. This is the very first time I'm seeing this. Very cool. So here's the story. And now what we're going to do next is we're going to generate images for this. And this is the second time ever that this runs. So let's see if this works. And when I say the second time ever, I really mean I've never even had this working on my laptop. So this is the second time ever that this runs. Again, this time we are going to go and break this story up into a storyboard. We're dispatching two things. First, to generate the storyboard. Second, to get the images from our model that's running on GPU. And again, I'm going to do a shout out here. This is a model provided for free by Black Forest Labs. This is called Flux Schnell. It is what, in my opinion, don't tell the people at OpenAI, the best image model there is at the moment. These are the images it just generated, just like this. If you wanted to, and wire up an audio and basically put your bedtime for your kids on autopilot, this would probably take another 15 minutes. I did not have that time, unfortunately. So that was my app. And with that, we're going to go, I think this is, again, I still don't know the numbers, 1, I think. I'm going to go back to this piece. So I was kind of spared the figurative tears. But this next session, I cannot promise you that that the tears are gonna stay away. All right, so what are the features that we're launching today? We're launching new enterprise capabilities. I'm gonna give you an overview of all of these. Some of these you saw, and then the message that I'm gonna deliver after is probably the bit. Anyway, so we are launching Premium Ingress. This is gonna be launched into public preview. Anyone that is running apps in production will want this. Anyone that wants to have a longer timeout on their apps because async is hard, or anyone that runs hundreds or even millions of requests per second wants to use Premium Ingress. It's the piece that will take you from thousands and tens of thousands of requests per second to hundreds of thousands and even millions of requests per second. Secondly, we're launching rule-based routing. You saw this earlier from Snehal. I believe it's going to go turn ACA into a whole new level of Swiss Army knife. I'm talking taking it from a mini to like one of those like really big ones that way down your pants, Swiss Army knives. And then private endpoints, which are being launched into GA. Private endpoints, if you have a desire to, have your ACA app running in private, but have your cake as well by exposing parts of it in public via API Gateway or AFD or anything like that, that's for you. We're also launching the following features. We have OTel and Aspire dashboard. Play with that. It's not .NET Aspire. It is Aspire. There's SDKs for all of the bits, all the languages. It integrates really nicely. It's well worth investing time into. We're launching plant maintenance, and then, as you saw, public preview of Durable Task Scheduler will also take place. All right, what did we see today? I'm going to go recover this one more time. Most importantly, we saw that you deliver apps and outcomes at any stage and do so fast. I'm talking like even a product manager can develop an app in 2 days, plus an extra 2 for the GPU image. But yes, in the future, even a product manager will be able to develop an app in 2 days, or in 2 weeks into production for NFL. Secondly, what did we kind of saw that. I was kind of alluding to that. You have an ability to choose your mix between performance and cost. Think of it as a slider. You're just moving left and right on ACA. I want to go fast, or, I'm just playing with this stuff and I don't really want it to cost a whole lot of money, but maybe one day I'm going to move that slider all the way. Okay? And then lastly, all of this is simple and powerful. All right, now, go to sessions. I have the honor of being the first guy up today. Sessions on ACA. Go to all of them. I'll promise you, they'll be even better than this. We have some real rabbits up. You're gonna be like, wow. Also, secondly, use ACA or convince your IT department to certify and let you use ACA. Thirdly, come and ask us questions. The whole team is here. You have 2 engineering managers here, all the product managers, everyone's here. So come up, ask us questions, any of the bits and pieces. We're happy to answer. And then lastly, hire Liana. And that was it. Thank you very much, everyone. Yes?